Welcome students. Today I am going over function chapter in your injective and surjective, either one and onto function related bijective type questions in the exercise 1.2 in question number 8. A question is there, let A and B the sets given that f of A cross B tends to B cross A and f of AB is equal to B comma A is a bijective function. Yes students, bijective means sure it is a 1 and onto either injective and surjective. So before starting this sum students, you click mark the IMP levels. It's a IMP questions. First of all, I go to a domain. Look at that. What is my domain? A cross B. I just take some numbers in the A1 given, A2 B2. A3 B3, A4 B4, that like all the many numbers available in these parts, that like that. I was taking only two data, either this and this. So for A1 B1 comma A2 B2, it belongs to a domain. What is the domain? A cross B, that value. So students, continuing the applying the domain, our definition is what? Belongs to domain then f of A and f of x1 and x2. A1 B1 same, A2 B2. Now check, what is your f of AB given? It is BA. So here similarly B1 A1 same, B2 A2, and now equality. B1 is equal to B2 and A1 is equal to A2. So finally you can say here there are two data is equal. Yes, A1 B1 is equal to A2 B2 because A1 equal to A2, indirectly pairing wise same. So definitely F is what? 1 1 function. Either it is a, you write down, it is an injective, therefore f is injective function. Now I go into our onto sides, the subjectivity, and then after bijectivity. So for onto checking, students, what is onto checking? Range must be define your codomain. Yes, check here. Every domain putting one by one in the fx f I and AB, you get the answer BA. Same I am picking f of A1 B1, f of A2 B2. Just type for example wise A3 B3. Similarly f of A4 B4. Similarly, you just change the answer BA. So here what? B1 A1. B2 A2, B3 A3, B4 A4, and that type of range is definitely, we can say B1 A1 comma, B2 A2 comma, B3 A3 comma, dash dash dash, many numbers, and that is called what? B cross A. Check, that's your codomain checking. Yes, it is your codomain. Therefore, what? F is onto. Otherwise, what? Surjectivity. Therefore, we can say it is your injectivity, surjectivity. So, F is what? Our bijectivity. These are finished there. Bijectivity function. And here you apply to finally this question for 8th one. Yes, now after ending students our bijectivity functions, I go to next one, question 9. Function I am given in end to end, one of the odd and one of the even, and check here also it is bijective or not. Students, I odd wise and even wise both I explain separately. First of all, for n is odd, what is the fn? N plus 1 by 2. And similarly, for n is even, fn is your our n by 2. So I am taking our natural number related some odd numbers, just like 1, 3, 5, 7. Surely you have to some answer. 3 plus 1 by 2, 4 by 2. 5 plus 1 by 2, 6 by 2. 7 plus 1 by 2, 8 by 2 is 4. Similarly, this side you are taking the some even numbers in the natural and you get the numbers. Yes, 2 by 2, 4 by 2, 6 by 2. Yes, it is repeated data. So we can't say it is your 1 1 either injective. So definition wise, you can show your drawing. 1 getting then 1, but 2 putting then also 1. Similarly, 3 getting then 2, but 4 getting then also 2. Then not 1 1. So I just taking here F1 is equal to F2 is equal to 1. So F1 is equal to F2. But 1 is never equal to 2. 1 is never equal to 2. So here, this definition wise, our function f is not 1 1. Either you can tell it is not your injectivity. Now I go to students our range and then I check onto or not, either subjectivity. So students, you getting the range after putting the value. What is the range? Range RF is your definitely 1, 2, 3, 4. Continuing if you put in the continuity in the odd and even. Yes, check. This is your n equal to your codomain. This is your codomain. Yes, they are exactly same. So it is your codomain. Therefore, I taking f is what? Here value for not 1 2. Here or 1 2. F is onto function. But what is my target? It is a bijective? No, it is not a bijective because it is not 1 2. If you 1 1 and onto both, injective and subjective both, that is bijective. Therefore, given f is not these are bijective function. And here students, these are question 9 is happily done. Now after that, I think students bijective not I am going to change question. It is a very most IMP sum in a board exam level. Given function f a r minus 3 and b r minus 1 f a to b fx or rationalized function given x minus 2 by x minus 3. Checking it is 1 1 or not. Yes students, it is 1 1 or not checking. So it is similarly I am going to first of all our 1 1 checking and after that our 1 2 checking. So this is your domain A. What is my domain? A, and A I have known r minus 3. So for we taking x1, x2 belongs to r minus 3. Definition wise, f of x1 is equal to f of x2. And applying the fx, this is your fx, x1 minus 2, x1 minus 3, same, x2 minus 2, x2 minus 3. Now making the cross multiply, x1 minus 2, x2 minus 3, same, x2 minus 2, x1 minus 3. And you just simplify after multiplications. So you are getting that x1, x2 minus 3x1 minus 2x2 plus 6, same is x1, x2 minus 3x2 minus 2x1 plus 6. This cancel x1, x2. Also 6 cancel. So what should be remaining? Minus 3x1, this one, plus 2x1 and minus 3x2 plus 2x2. Also then I am getting minus x1 is equal to minus x2. So x1 is equal to x2. And these are conformably we can say it is 1 1. Therefore f is your 1 1 function. Either you can say it is an injective function. Now after that I check to our range wise. So for onto checking then range. So suppose given question y is equal to fx and y fx is what? X minus 2 by x minus 3, where x may 1 equal to 3, and that these are belonging continuity. Just you make the cross multiply and you just find out x value one side. Then you get easily our domain sides. Yes, students. So I just define the values for x separately in the terms of y. So here y with the one value x minus 3 and your x minus 2 is same. So yx minus 3y. Look at that, this x and this x I make the same. So what you getting? Yx minus x is equal to 3y minus 2, x common. So exactly your x value is 3y minus 2 by y minus 1. Here also y is not equal to 1. Otherwise they are not valid. And one more time I repeat, yx minus 3, yx minus 3 by x minus 2, yx minus x and 3y minus 2 and y divided by 1. So here y is equal to what? R minus 1. Then they define, and that is your what? Domain for particular our questions. Now I find out range. To find our range, definitely range wise is going to fx, students. What is your fx? This is your fx. Our x minus 2 by x minus 3 and apply your domain 1 by 1. And what is the domain value for? 3y minus 2, y minus 1, same. 3y minus 2, same. And this calculation is definition for the range. So 3y minus 2 minus 2, 3y minus 2, y minus 1. So finally I get 3y minus 2 minus 2y minus 2. Same as here, students. Plus 3. This cancel are easy. I getting only y. And upward also this cancel only 1. And what is the y? R minus 1. And it is called B. Check your question again. Yes, it is your codomain. What? Therefore, finally I write down your answer. So, f is onto function. Finally, f is 1 1 onto both. So, f is what? Bijective function. And that's finally our this question is happily here done. It is an IIT question at students exam level. Now continue, students. Our next question for 11 and 12. Continue our exercise. It's a very easy MCQ. First of all, I am going to 11. F given R2R and fx given x raised to 4. And options given related 1 1 1 2, not 1 1 1 2, on 2 but not 1 1, either both. So very easy. So first of all, I go to our fx given x raised to 4. So what is the domain? Yes, domain is your given to R2R. You just taking some numbers related 1 either minus 1, either 2 either minus 2. So what you getting? Here 1 1, here 16 16. It is repeated. It means it is not our 1. If you 1 put in, answer is 1. Minus 1 put in, then also 1. Either in 2 and minus 2, then again it is 16. So finally, f1 is equal to f of minus 1. So f1 is equal to f of minus 1. But 1 is not equal to minus 1. It means confirm f is not 1 1. That's your one side answer. Now for every x belongs to real, what is the square? Yes, square is always non-negative but 0 possible. Again taking square because I want x raised to 4. So what you get x raised to 4? Greater than or equal to 0. It means your range is 0. What is my range? Close bracket 0 to plus infinity, but it's never equal to R. So it is our codomain. They are not same as to our range. It means conformably F is not onto. So not 1 1 not onto. F is neither 1 1 nor onto. Your answer is purely here given. Yes, students, this is very easy. One more question 12, same options, but fx given our 3x. You know, students, 3x means x raised to 1 power. Linear equation always, students, 1 over and 1 2. In this answer is A. Don't worry, I explain the method guys. See the method, very easy. For I just taking x1 x2 belongs to our domain. Domain wise, I just taking out our starting solutions. So my question is f of x1 is equal to f of x2. Applying that, 3 of x1 is equal to 3 of x2. 3 3 gone. You just only getting x1 is equal to x2. Yes, it's the one. So f is 1 1 function. Finally, one case is done. Now I go to onto wise. Here also I explain by the in general. Suppose here you not start a number wise, students, because there are many numbers on this line. Suppose 1 is equal to fx, which is 3x. What is x? Y by 3, and that called our domain where y belongs to R. And applying the fx, students, in the fx value I put it. What is my fx? Y by 3. In place of x, cancel. You get only y, and that is the R. And is equal to what? Is equal to our codomain. It means surely it is your onto. Therefore, is equal to codomain I showing. So lastly I telling, therefore f is also onto function, and that's my our finally answer 12 to A options, and here our D options. Yes, students, here our 1 1 and onto topics finished here. Now I start our new topic. It is a composition functions. It is a very most IMP topic. Just after that our ending. Yes, now students, I go to new topic, composition functions. Students, composition functions is nothing but two functions mixing each other and they create the new function. Yes. Here I give you one little example by this drawing wise. Here function f is defined only a to b. Only looking in that f is function defined into a to b. And another function is g. This is g functions. Is also defined by the b to c. If you both mixing, then you get the answer GOF. It is a F composing G. Always reading wise the back side. F composing G. O consider here composer. Compose means you mixing the both functions. So I just going to the basic definitions and the basic conditions for this function. Here F function is what? A to B. Yes. G function B to C. And first of all, condition for GOF. Every GOF have some conditions to always apply. Range, subset, domain. Again repeat, students. What? Range, subset, domain. Reading to back side. GOF we prepared. So range of F, domain of G, because actual reading is this, F composing G. Okay, because first operating F, after that operate the G. So here range of F, subset domain of G. What is range of F? Range of F is a B. Subset domain of G. What is domain of G? B. If this is true, then B is any set, but B is a subset of itself. Then it is surely GOF is exist. And where it is exist? Exist is that F the starting point, G the ending point. That is the condition. Don't worry students, I again explain you by the different example wise. Also I checking to F4G. If you drawing change, here G right and here F right. Different drawing. So drawing is again I draw, don't worry, for your better understanding. Here your A, B to C. Same going to here are parts of A and G and here parts of F. And here you apply to Gx. And these are criteria to here X and here apply to our F of Gx. Students, drawing not important, don't worry. You just important to these functions understanding F of G. Yes, same as going to, but this function I change here A to B, B to C. Then your conditions here different. See what is the condition? It's very easy. That is the range subset domain. Same apply. But what is the range of G? Domain of F. What is the range of G in this parts? Because here I G taking A to B, F taking I B to C in this one. This different, this different. Okay. So what is range of G? Range of G is a B. Subset domain of F is B. It is true. Then our F of G is exist. Okay. Don't worry students. I explain you by the little example wise that type of numericals. In only condition wise and extra applying to one more numericals. Only explaining the conditions. Listen here students. Extra sums. If I taking F function in any n to n here and G I consider to z any, just like fx I taking, any for I taking here x plus 1 and here 2x, and checking for our f of g and g of f. So first of all, for I checking first f of g. What is condition? Yes, condition is range subset domain. Range of G, domain of F. What is range of G? G range is that. Domain of F N is not true. It is false. Because generally known N, W, Z, Q, irrational. These all are our validity. Z is not subset N, but N is subset Z. So here false. So F of G does not exist. In this case, this part is not possible. Now I say going to further cases to G of X, then also similarly explaining. But students, here condition is necessary. You first of all checking the now for I doing our G of F. Same range. Subset domain condition are there. What is condition? Range subset domain very easily, and range of F domain of G. What is range of F? F range and domain of G Z. It is true. Yes, it is true. So our G of F in which they earning F started and G ended. F started is N and G ended is Z. Is exist. Here our the exist. Now I define exist values. G of X by G of Fx. O you consider in the bracket wise Fx. Now what is the Fx students? X plus 1. I just here put it. After checking our condition and here x plus 1 is equal to something assumption. What assumption? T. So here gt. Now gt checking in the gx. It is 2x. So I write down 2t and this t students putting down there x plus 1. You get the answer to x plus 2. That answer is what? G of x. This is your new answers. For after composition, F compose in G. Here not exist, but here exists. So that is your answers for your extra sums. Now my students start little sum, first one in further exercise. Now students, I continue our exercise 1.3 to first sum. I have given 1 to 3, 4 and 1 to 5, 1 to 5 and 1 3 and that types of functions given. But asking here GOF. You don't reading here GOF either form. It is nothing. It is GOF means what? F composing G. Backside reading. F composing G. So I first of all check the condition. Yes. So students, condition is what? For GOF, range, subset, domain. Every time this reading and backside putting here range of F, domain of G. Now check what is range of F. F range in the belonging to 1 to 5. Subset domain of G 1 to 5. Yes, it is true. It means what? Yes, GOF is exist in where exists F running in 134. Sorry, in 134 tends to G ending in the 13. Here your condition in 134 to 13. Now I start their solutions. So first of all GOF, what the first value? 1. G F of 1. Same GOF 3. G of F3. Same G of F4. G of F4 and value. Okay, students see here F1 in the F line reading here 1. Yes, what is value? 2. So here G2. Now G2 reading in the G function. What is G2? It is 3. So I just taking it. Same as here. G. What is F3? In F of 3? Yes, it is 5. But what is G5 now? G function is 5. It is 1. Also, check the next one. G, same. What is F4? This F4 in F line, check here 4. Its answer is 1. Now G1. In G1 is what? 3. Check this answer is only belonging 1, 3. So that's why I am checking the condition first. G of X, 1 taking them, answer 3. 3 taking them, 1. And 4 taking them, 3. That's answer here, G of X. Students, here textbook question finished. But I show extra for your knowledge. F4G. What is condition? Yes, condition is a range, subset, domain. Same result. Here G, here F. What is range of G? Range of G is a 1, 3. Subset, domain of F 1, 3, 4. Check. It is true. Then you continue. Yes, it is true. Therefore, F4Gs exist in where exist? Yes, in the FOG means G starting first. 1, 2, 5 tends to. Now our next F ending. What is F ending? 1 to 5. Again repeat. G started when taking 1 to 5. Here G started and F ending means again the 1 to 5. Now I start slowly one of the one. Domain putting, students. This domain putting. F4G 5. So F composite G1, F composite G2, and F composite G5. Now the value is ready. Check. G1. What is G1? In the table of G1, answer is 3. Now what is F3? In the F table reading here 3, it is 5. Same. Here G2. What is G2? In the G2 line, it is 3. So here 3. But now what is F3? F3 is 5. One more. And G5. What is G5? Yes, it is 1. But what is F1? F1 is 2. Check this answer is always belonging to a range. That's why I first check the condition. So F4G value finally done 1 then 5, 2 then 5 and 5 then 2. And here students, our this value is a happy number over here. Correct? Yes. Now your first question is finished. Now students, here our these explanations for exercise 1.3 first question done here. And composition function related further numerical students, I explain you in the next part. Okay, bye bye, see you.